Good morning, everyone. We're Team 9. That's Cody, Joel, Stephen, and I'm Rishi. Today, we present to you the ultimate challenge of Insanis. Insanis is a very complex mechanical puzzle. Well, the name Insanis comes from Latin for becoming insane. And our idea behind that was we hope this does drive all the puzzle maniacs out there as insane as it drove us while making it. And well, why we chose this idea, we came up with we came up with at least 3 or 4 different ideas that we liked personally, but none of it was something that we all liked together. And all our backup ideas happened to be the same. It happened to be this puzzle, so we decided to look at it further, and it was a very complex mechanical design, and we thought that it would be a challenge to us. And keeping in mind that at the end of it, we wanted a puzzle that would go out in the market as something that no one has ever seen before and be able to sell it. That's why we decided to go ahead with this. Let me hand you off to Stephen.
So I'm going to talk a little bit about the design procedure itself. Basically, what we started with is an internal gear train, and then that gear is connected to the opening, and by having external pins, which you can actually see here, and then you can see on our CAD model the holes for them, we actually use those to either push pins onto or pull pins off of the internal gear train, so that when the internal gear train can move, the entire assembly will be able to open. So yeah, to start with, the connections between the fixed gears are actually shown there. You can barely see it, but there are circles, and so I'm talking a little bit about how we designed it itself. We had our outside thing, we built sketches on the inside, and then did all the machining design from that. If you go to the next slide, you can see that the arrows actually demonstrate which pins do what. If by moving them in, you unconnect them, and by pulling them out, you disconnect it. At the same time, you can see we actually put in a dummy pin so that one of them just doesn't do anything, so that if you're messing with it, you're wondering why isn't this one doing something. Here you can actually see when all of the parts are in there. We have the one gear on the side is actually connected to the base itself. The other gears are the train. When those gears can move, the entire assembly will be able to open. If you go to the next one. Now I'm going to hand it off to Joel, who's going to show you and tell you a little bit more about the assembly itself.
All right, so here you can see a completed CAD model of the complete assembly. We've eliminated the top, obviously it's on here, just so that you can see all the internal workings. This is in the locked position, so some of the pins are in the in position, some are in the out position, but all of the fixed gears on the pins are interlocking with the gear train in the center gear train. Here you can see the unlocked position where some of the pins we pull out, thus releasing the gear train so that when the user wants to finally open it up, when they've unlocked the puzzle, all the gears can move, showing how that they've unlocked the puzzle. This would then be in the open position. There are hooks there that would rotate off of the pins so that the user could finally open up the puzzle. On this next slide, you can see a video of how that gear train would work, simulating a child opening and closing the puzzle. Hopefully it works. Is it not going to work?
It's loading.
So this here, we have obviously a lot of gear constraints, a lot of pin and slot constraints. Spent a lot of time getting this model to work. There you can see how that would work. One of the sides opens and closes. You can see all the gears rotating when all of the pins have been taken into the off position. And then Cody will talk about the physical prototype.
So for our physical prototype, you notice this white plastic. It's actually Instamorph, which is a low melting temperature thermoplastic, and so we used that because a lot of our dimensions were non-standard. So when trying to actually create the device, it wasn't easy to just like drill a hole that you could insert something into. But using Instamorph, we were able to just melt that pin area and then slip the pin in and then constrain it like that. One of the big issues that we had when we actually noticed our scale was this is pretty large, but we couldn't scale it down because we designed using Lego Technic gears. One of the other things, yeah, we can skip that. No, go to the next one. This is just some of our designing when we were melting it, heating it up, putting everything together. The Instamorph made it a lot easier to actually put axles and things into place so that they would fit together. But we ran into some issues. There was a lot of play with the gears. So when everything was put together, it moves, but it doesn't exactly keep you just forcing open the actual mechanism. So as you can see, the scale was too big. Complexity of the design made it so that all these parts, if we tried to just machine this and put it all together at once, it probably would have not worked. And then, like I said, there was a little play on the gears. So if we actually built this in a new future iteration, we would definitely kind of stray away from the gears and more towards solid parts that could be easily manipulated, just like solid geometry that when you twist, it interlocks or it doesn't interlock, rather than try to rely on gears and axles that may have a lot of play. Any questions?
Two questions. One, does it work?
Like I said, there's a lot of play in the gears,
Okay.
but otherwise, everything when it comes together, if the gears didn't have a lot of play, yeah, it would. Because basically, when you push this pin in, these gears they would hopefully not move, and so when you open, you can kind of see some of the gears move on the inside. But basically, when I move this, you see this gear move a little bit, and really this should move with it exactly.
So we were dealing with basically too much internal friction within the gears themselves. So like Cody was saying, if we wanted to do another iteration, what we were going to try to do is, instead of having a gear set here, actually have a lever arm, and so have our pins basically stop it at that level instead of having gears on the inside.
And so is the motor constantly going?
No motor.
and-
No motor.
When the child has figured out how to open it, they pull it open, and you can see all the gears rotating. So there's no motor.
What makes it a challenge?
Ideally speaking, well, even when you can't quite see it, but you can tell from our CAD model when the pins are pushed in, and one of them's out, it actually pushes the levers from. I think you can actually potentially go back to the correct model, pushes fixed gears onto the gear train so that it won't rotate. And so the challenge is figuring out which pins need to be in which configuration for it to open up, or for your internal gear train to not be stopped.
But if you saw in our first sketch of the idea behind it, basically you would have certain cutouts in the top where you could see into the internal mechanism, but you wouldn't exactly know how the internal mechanism works. So you'd have to figure it out in order to figure out which configuration the pin should be in. But when you have a certain link,
How many pin motion combinations are there? I mean, is it large enough that it would stay a challenge? I mean,
yeah, we were thinking 2 pin combinations in reality. So then,
Each pin would have an in and an out position. Only one of those positions would unlock all of the gears. So in this model, we obviously have 4. In the CAD model, we had 8. So 2 to the 8th power gives you a lot of combinations. Only one of those would unlock it, thus giving the name Insanis.
Also, the one issue that we saw is we did not add the other side, and the main reason for that was we had time and material constraints that we couldn't actually meet. So.
Just a clarifying point. Well, two-part. A clarifying point and then another question. So does the pin combination change is the first question. So once they figure it out, they'll know forever
Yes.
how to unlock the toy.
Yes.
Okay, so that would be something to work on for a future iteration because you want a kid to want to play with this multiple times if you spend money on it. Second question is, what was the key demographic that you guys were targeting? I didn't catch that earlier.
We targeted mostly people above the age of 10 years. Well, that was just an age we came on, but basically it's more towards people who are crazy behind puzzles, who just want to get something new after they're done with something. And I think having to the power of 8 number of solutions, possible solutions to this with only one working, would take a lot of time to reach there. So that's what we're targeting.
I mean, in the big scheme of things, you can imagine a smaller puzzle that it's just a small trinket, and maybe it has these simple mechanisms. Maybe you get a pack of 5, and they just look cool, and you can set them on your table, and they're just aesthetically pleasing. And you just, people when they come over to your house, they're like, hey, what's this? And then they try to mess with it. So it's not something that you may play with all the time, but something that you just love puzzles, and you're like, this is a really cool puzzle.
And I noticed that you left the material white. Did you think about maybe painting it or?
Yeah, so I guess in my vision, you could also make it something that's just, like I said, aesthetically pleasing, something exotic, maybe any type of nice wood. But the reason this was left unpainted is the instant morph. As soon as we started painting it, you wouldn't be able to morph it, or you wouldn't. It would start contaminating.
Again and again. We had to keep heating it to change the way it works, because our design was all handmade the outside, and every time you would melt it, the paint would go away. So till the end, we were working on it to make it work as much as we could. That's why we didn't paint it. And we also plan to have bits and parts to be clear plastic, so that you can look into it. So the top might not be the same material, might be something else.
Originally, was the outside casing 3D printed?
Yes. But there was a constraint again.
On the build volume, so we couldn't make
All
that.
that would have been printed and it would have worked. It would have been printed, and that way everything would have been toleranced very nicely. But that was a constraint that we ran into.
And like I said, we would have scaled it down, but we were planning on using the Lego Technic gears, which are a certain size. So. Shelton? That was actually our first idea in the running, is to develop something like that, but in terms of complexity, super complex in order to make it so that a user can actually change the different types of gear sets and positionings.